Okay, so good morning. So Trenton, you're right. Everybody is in hangover. As expected. Yeah. Where's the young guys that we had yesterday? Not here yet. Okay, we'll meet them. Yeah. Well, actually, I'm in jet lag. I came from the US, and for me, every day is to recover 1 hour of time zone. So good calculation. 5 days. Tomorrow I'm fine, and then I'm flying back to the US. So for me, it's great. So thank you for waking up this morning and coming to our session today. Actually, for me, it was great to listen yesterday for all the presentations. I started as a programmer in Natural. First, I knew COBOL, and then I moved to Natural. That was the history. Thank you, Nicole, for introducing me. My name is Eli Cohen, and I'm the product manager of Natural on the different platforms, Natural One, Natural for Linux and Cloud, and the ESM product and the Kronos tools. So in my presentation today, actually it's split into two parts. My first part is to talk about about the distributed architecture and focusing on the application where Natural resists. And then followed by Ilan, he will present the Adabas cluster. So let's start. So I believe everybody wants that the business will continue, that the application will work all the time. And there are two aspects of that looking into that. Yeah. So in the right side, we see the disaster recovery. When something wrong happened, then if the network is down, nature disaster, or any kind of impact to the site itself that could cause your application to be down, then you want to be also to continue from a different site. And there is the other side, which is the high availability, more focusing on more drill down about your servers that they are high available even in the same site or could work on a different site. And this actually will lead us here on my presentation. So looking on technology or in architecture, if I'm looking on two edges, so we have on the left side the monolithic, which could be one server, one database, which could also be on one machine, one program that holds the UI, the business logic, and the data access layer. And on the other edge, which is everything is distributed. There's no right and wrong in this one. Which one is better? Which one is worst? It could be something in the middle, but just this give you, I would say, the range between both of them. In the monolithic area, there are some challenges. One of them is, like I mentioned before, you want that your application will always be on, and there is a regulation that's running now in Europe, and I heard that it might be also goes to the US. It's called DORA, Digital Operational Resilience Act. I was also participating in one of their webinars, and one of the principles was that your application needs to come back as soon as possible. And I ask, what is as soon as possible? Is it hours? Is it days? Is it seconds? And I think this goes back to my first slide about DR and high availability. So if you have DR, your application will come back, and the high availability is how fast it will come back. And this is actually what is happening in the monolithic, that it will come back, but it will take you some time to bring it back. In the second part, where we see the volumes, when there is a failure, then you can lose the data entry. And I will give a personal example from my life that happened to me in my next slide. Scaling, if you wish to scale, sometimes it takes time to do that. And if you do upgrade and updates to your application, then you need sometimes to have a downtime to your application. In the distributed architecture, I see those three advantages very unique to distributed architecture, and I see it as a story. Yeah. So if you have, if you eliminate your single point of failure, this means you have multiple servers running in your data center or different data center, and once there is a problem and you detect it automatically, and you have a reliable crossover, this means that you move the user from one server to another server without him notice that, then you are in a good shape in your distributed architecture. So now let's talk about our product, our new product that we launched in October 23. It's called Natural Availability Server. It's available for you to test and try. And I will explain how we are addressing those three advantages that I just mentioned. So the first thing I mentioned is single point of failure. We have two servers, at least two servers. You can have more. It depends on you how many servers you wish to have. It could run on VM or pod. And we have the natural application distributed in both applications. We have also the natural availability server. This young guy in the middle, it's called Redis. It's a state server, and this is the part which helps us to save the context and to securely pass it between the server. So at the beginning, user connects to the load balancer. It could be on-premise, it could be on the cloud. In HTTP, we have a new user interface, and once it's connected, then it's directly to the one of the server. And we know this is the first call, and there is a difference between the first call and the second call and beyond, and I will explain this in a minute. So in the first call, the user directs to one of the server. Our natural availability server detects that, process the request. At the end of the request, save it to the state server, and then terminate the natural session. And now something happened. It could be that this server is down. It could be that there is a failure or different failure, or it could be that you decided that you will work in round robin, once here, once here. And then in the second request, user connects again, and it goes to the next server, because this is the decision that was made. And now the first part is, we know this is the second request, so first we retrieve the session context, process the request, and at the end, we save the session, and the session is terminated. And this will continue on and on and on and on. You can work also in sticky mode or non-sticky mode. It depends on you. We support both ways. Now for the story with a glass of water. So I was sitting in a bar with friends, and as I would call it new immigrant in the US, everybody gets insurance for the car, and I realized that I pay too much, and I was thinking I need to improve that. So I went back to home. I told my wife, I have a way to save some money, and she said, great, do it quick, and come back to the kitchen to help me. And so, okay, so I was sitting in front of the computer, taking the glass of coffee, and taking my social number, my history, and start typing the information and going through all the pages that I was there. And then I reached the point where I need to click the button and then get the quote. Do you want to guess what happened? I was holding the head first because I need to go back to the kitchen immediately. And the second is it's failed. Most probably because something happened, maybe server was down. And I think this is a good example from our life, yeah, that we are doing something and something wrong. Okay? So raise your hand, whoever clicked a button on a web page and it had a failure. I see you maybe see many hands, but I see many leads for sales. So this is great. So let me explain how we solve this. In HA mode, which was my case, I got the first screen. I typed and I typed and I typed. And then I clicked the PF key or enter or any button. We have the network latency process, and then it failed. In HA mode, when we turn it on, then this green is saved. Once I click the button, once I get the first screen, then I tapped all the information. We have the network latency. Now we reach to the point where our HA mode detects that there is a failure, and it's directly to a different server, and then we set the context. This is called data entry recoverable. Okay. As mentioned before, we have a new UI that you can use. You don't need to install terminal emulation on each and every end user, and it's actually helping us. We will also introduce some more functionality in those terms for a token-based solution in the future. It will help us to even do some more things in that area. Okay, so how do we get there? How do we get to the distributed architecture? So, as I said at the beginning, there is no step that you say, this is right for me and this is wrong for me, or we say to you, this is right or wrong. This is what the business needs, and this is what you can achieve with the business. You can start from the beginning, and you can stop in the middle because this is enough for me, or you just say, okay, I want to go to the high end and would continue to have my application with high availability. So first, you need to set the goals. You need to understand what you really need from the high availability, and at the end, we can, of course, support you on this transition to decide and help you to do the high availability. So on the right side, you will see diagrams how the high-level architecture looks like, and on the left side, what are the benefits at the end with the full distributed architecture. Once it will turn to green, then I will explain each one of them, what's the meaning. So we start with the monolithic. So in the monolithic, you can have one server in your data center and one in disaster recovery center, and you can have like an active passive. So it's not a full disaster recovery because sometimes you can lose data in between. The next step is if you split the natural server into two, one to have the online sessions and one for the services. So the services is actually, what you will get is that the services are resilient because services are usually few second requests. So each time you call them, then it's open, close, process, and then go back, then you have resilience. But on the other side, on the online session, you still don't have the resilient, you need the high availability. You can somehow do scaling by letting all the users to log out from your server and then add new server or make an upgrade and update. And this is, again, something that you can achieve right now without any product. It just depends on your application, how it's built. The next part is to add Adabas cluster, where you can have it on a different data center as well. As mentioned, Ilan will more explain about this and with more deep dive. With the database cluster, then your database is resilient. Now you support fully disaster recovery because it is spread also, the database is also spread on different data centers. And we're still missing the other part, which will be filled with the high availability, the natural availability server. The online session are resilient. The data entry that I presented before are now covered. You can do auto scaling because you have reliable crossover. And the same is with the upgrade and updates of the applications. Okay, now let's look on the product, how it is built. So this is more about to give you an impression what needs to be done in order to have fully distributed architecture. So on the right side, we have the service consumer. And the left side, we have the session consumer. We have the load balancer. On the right side, you can have entire rigs and your natural subprogram exposing the services. On the left side, you have the natural and natural availability server. We recommend that they will be on the same server in terms of performance. And we have the Redis, which will bring you the state server. And in the lower part, we have the Adabas cluster with primary and secondary. Okay, so what are the benefits of the high availability? And actually, this is a summary of the presentation. So whenever there is a business demand for high or low peak, then the high availability will help you to do the scaling. If you're running in a DevOps mode and you need to increase the deployment cycles and to avoid downtimes of the application, then the natural availability server will help you in that to avoid downtimes. If there is a failure, and as I said, we monitor the failures and we detect them, then your application will be resilient. And if you're running, as Guido presented yesterday, in a cloud native mode, and you're paying to the cloud based on hardware consumption, then you can just play with it and just lower the number of instances and have a cost efficiency. So this was my last slide. Any question?
Go back a slide.
Which one?
Back that one.
This one? This one? Yeah. Yeah, it says VM or pod.
Oh, okay, sorry.
Yeah. Yeah. Yeah, and I will try to promote another thing. So we are planning to have soon Natural as a Docker image that you can download directly from our service containers. Soon. Yeah. We are continuing with the same. Yeah. So if it's ARM or Intel, so we'll continue with the Intel. I don't hear you. Yeah?
Is it on now?
Yeah.
Right, thank you. Were you inspired by the company Tandem Computers? They offered the concept of redundancy on a lower level, but they also provided double hardware, disk storage, processor, and so on and so forth. So, but not on your application level, but rather on the operating system level.
Yes.
Have you heard of them?
Yeah, I didn't hear about them specifically. I know that we have, I think, in Tel Aviv Stock Exchange that they did something like that, but it doesn't give you the solution on the session context, because this is something that we just added to improve also the user experience.
Good morning, thank you. A quick question. Are you sure you really want to only do Intel? Because the reason I ask is, of course, Apple's going to silicon for every third con. So I'm just curious, as things become more, platform independent, are there any future plans to explore, expanding beyond just Intel processors, that sort of thing?
We will write it down and consider this, but you first need to move to New Jersey to help the MVC. Any more questions?
Well, thank you so much.
So I will hand over to Ilan, so he will continue with the Adabas cluster.
Thank you, Eli.